Hello everyone, greetings from RWTH Aachen University. My name is Boensch, and today I'd like to encourage a discussion on a research interest of mine, which is the issue of joint locomotion with virtual agents through immersive virtual environments. Joint locomotion thereby describes a social group of computer-controlled human-like entities and human users who interact directly and plausibly with each other while standing in or moving through the virtual scene. In real life, such dynamic social interactions are an everyday phenomenon. However, when analyzing these well-known interactions, we have to conclude that, while it looks easy, it's not. Instead, a non-trivial interplay between non-verbal and verbal interactions takes place. Walking itself is already a complex endeavor with, for example, situation-dependent speed and orientation changes, as well as changes between mobile and stationary contexts. Walking in interaction, furthermore, has an intertwined organization of walking and talking. This means that both mutually shape each other. To this end, they need to be considered together when realizing virtual agents as virtual companions. In the literature, there are various applications focusing on agent-agent interactions during locomotion. Interestingly, however, most applications avoid the dual tasking situations of walking in interaction with respect to user-agent interaction. However, I am convinced that closing this research gap is beneficial for different use cases. For instance, guided tours or social simulations will become more realistic and engaging if a user is really able to traverse a scene as a member of a social group. A small foretaste is surely given by various computer games in which you are already accompanied by NPCs. However, when simulating these joint locomotion scenarios in VR, various aspects for the behavioral design of the virtual agents need to be carefully considered. 3 of them are exemplarily covered in my short presentation, namely kinematic parameters, group shapes, as well as being a virtual converser. Before I give more input, I kindly ask you for any feedback you have. Specific questions I like to put to you are: do you see specific use cases which can benefit from dual tasking? Do you miss certain behavioral aspects, or do you consider certain behaviors more or less important than others? And do you know papers and approaches which already realize some of these aspects in a user-agent interaction? I'm looking forward to your input in the introduced channels. Alright, back to the interaction dynamics, starting with the kinematic parameters. Of course, the virtual agent's locomotion need to be realistic as well as predictable. It needs to adapt to the present environment and also to the human user's locomotion. While some obvious kinematic parameters are listed on the slide, finding suitable values for them is non-trivial. To start, we need to validate whether mimicking the reality is fine, or whether some deviations or variations are also accepted or even preferred by the users. Therefore, it needs to be analyzed if a user walks with a group of virtual agents in VR the same way as they would walk with other humans in reality. Initial findings already confirm this for a one-to-one constellation. However, more insight in the appearing navigation pattern is required. The next interaction dynamic are group shapes in mobile and stationary contexts. Complicating matters, these shapes are highly dynamic. Group shapes in stationary context are mainly influenced by various environmental and conversational factors. Luckily, arrangements like, for example, the F formation can be used to describe the settings between entities very well. We face more complexity when changing to mobile contexts. Here, people can walk in different formations. The group's entitativity, so the spatial coherence of group members, can change, or the group behavior of reaching a goal can change. Some members might not know the goal, which changes their kinematic parameters, or groups may split up to reach a goal, or they may stick together. All these aspects change the impression of a group, for people watching from the outside, but also for the group members themselves. A third aspect I want to mention for the interaction dynamic is the talking and listening behavior of the virtual agents as virtual conversers. Of course, it needs to be plausible, thus verbal aspects like speech need to be taken into account, as well as body orientation, gazing, co-verbal gestures or turn-taking, while always considering the locomotion context. Thus, realizing the walking and interaction for VR scenarios is a non-trivial but a worthwhile endeavor. A meaningful coordination of the aforementioned aspects is substantial, while virtual agents also need to be able to anticipate the user's intent, allowing them to react in a human-like manner on a user's actions. The virtual agent's reaction can thereby be realized verbally, or they can be silently embodied. Thank you for your attention. Now let's discuss the issue of joint locomotion with virtual agents, while the reference will be shown for a few seconds.